So, very good evening to the students who have joined. Can you please write in the chat box if my voice is clear and my video is visible, and also if you can see the presentation. We will wait till the other students join, then we will start today's session. Okay, thank you so much. So, let's wait up to 2 to 3 minutes and then we will start today's session. Yeah, very good evening. So, again, good evening to the students who have joined. We will wait for 2 to 3 minutes till more students join, then we will start today's session. And meanwhile, if you have any problem by for hearing my voice or looking at or seeing the PPT, please write in the chat box. If you have any problem, otherwise it is fine. We will start soon. Yeah. Okay, so it is 6 p.m. and I think we can, okay, how can we prepare for objective written examination? Okay, so the objective written examination, I will suggest that you cover all the topics what are in your syllabus from the medicinal chemistry while looking at the videos and attending our classes, and from that you will have the perception of the concepts mainly. Okay, so the now after that I have suggested few books for medicinal chemistry in the last class, I think. So I will suggest you can read, start reading from that, and in the NPTEL website I think you will get some previous year's question for the final examination, and I think from that you will have the help of preparing the examination. Okay, because I am only TA for this course and for the online classes, so for the final examination I don't have that much idea, but in the last class I will try to I think sum up the whole syllabus and how to write everything up. So I think it will be helpful to you. So now I think we should start our class. So very good evening to the students who have joined. My name is Moshumi Dev and I am the PMRF fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. Today it is the week 8 live session for our NPTEL course of Medicinal Chemistry. Here in this week 8 live session we will discuss our week 9 course content. We will discuss around 20 questions, 20 MCQs related to your week 9 course content, and regarding that we will in detail we will discuss the topics also. And like every day, if you have any doubt after any question or about anything, you can write in the chat box. I will answer those questions after taking the answer from you. And just like every day, please try to answer the questions. Okay, as I am showing you some question, please try to answer it. It does not matter if your answer is correct or wrong, because here it is not any examination or anything. But it is very important for you to participate in the class to know that how much you have learned till now. Okay, so today we will discuss week 9 course content. So I hope the PPT is visible and my voice, everything is clear. If you have any problem by looking at the PPT or for say hearing my voice, you can write in the chat box. Okay, so I think we will start our today's session. So after every question, please try to answer that question. Okay, so the first question, it says that which of the following will not be a limitation of a prodrug? Number A, formation of toxic product. Number B, an inert carrier can be cleaved off forming toxic product. Number C, product cleaving off before reaching the target site. Number D, the cleaving of the carrier is also site specific. So which of the following will not be a limitation for the prodrug design? Try to answer this question. Which one of the answers you think should be the correct answer? Okay, so I have one answer, the number A. Okay, others also try. Read the question carefully, read the all answers carefully and try to answer it. We will eventually discuss the question and what is prodrug design, what are the limitations and everything. So the question is, which of the following will not be a limitation for prodrug design? And your options are as follows. Number A, formation of toxic product. Number B, an inert carrier can be cleaved off forming toxic product. Number C, product cleaving off before reaching the target site. Number D, the cleaving of the carrier is also site specific. So let us check. So I think the PPT is visible to you. Okay, so we have two answers, number A and number D. So let us check out. So at any point, if you have any problem by for hearing my voice, please let me know in the chat box. Okay. Okay, so let us check the answer, then we will discuss this question in detail. So, the correct answer is the cleaving of the carrier is also site specific. So, it is not a limitation of prodrug design. Now, what is a prodrug and how to design a prodrug? Okay, so the prodrug, okay, let me just show you the first. Okay. So, it may be little bit of not clear this picture, but once I share this PPT with you, you can check it from there itself, and it will be clear at that time, but right now I will just dictate the things. So, the prodrug is a pharmacological substance administered in an inactive form. Once administered, the prodrug is metabolized in vivo into an active drug within the body through metabolic processes such as hydrolysis of an ester form of the drug. Sometimes drugs are designed to use metabolic process in order to generate their active form. This is done in order to improve some selected property of the molecule such as water solubility or ability to cross the membrane temporarily. So, what is a prodrug? So, prodrug, sometimes what happens when you are given a drug, so sometimes it is difficult for that active form of the drug to get solubilized in our system or to get access from the membranes. Okay. So, to that time what happened, to increase the access to the membrane and to increase the solubility, what we have to change some functional group of the molecules, and the change should be in such a way that in our system the molecule hydrolyzed or get metabolized in a way that it will generate the active form of the drug. Like for example, sometimes what happens, if a molecule contain a carboxylic acid group, so sometimes it is problematic for that body to get absorbed in our body due to some reasons for the carboxylic acid group. So, what happened, the carboxylic acid group can be converted easily into ester functional group, and we all know that the ester group easily get hydrolyzed to the carboxylic acid group. So, the drug can be given to you as a ester, you are taking the drug as a ester form, but when it is reaching your system by using various mechanisms of the metabolism of the body, it gets hydrolyzed into the active acid form and it then works at the drug. Okay. So, that ester form which is given to you as a at first, that is called a prodrug, which will be converted to the active drug form in our body. Okay. So, what is the limitation? What are the limitations of the prodrug design? So, formation of unexpected metabolite from the total prodrug may be toxic. The inert carrier generated following cleavage, the prodrug may also transform into toxic metabolite. During the activation stage, prodrug might consume a vital cell constituent leading to the depletion. Okay. The limitation of the prodrug designing is the formation of unexpected metabolite. The inert carrier can be cleaved off, forming a toxic molecule, and prodrug might consume vital nutrients. Okay. If the carrier cleavage is site specific, it is an advantage. Okay. So, for our what is the So, from the question it was written that which of the following will not be a limitation of prodrug. So, as you read, so the first one, formation of toxic metabolites, so it is a limitation of the prodrug. An inert carrier can be cleaved off, forming toxic product, it is also a limitation of prodrug design. Okay. So, the formation of toxic product cannot be happen in case of prodrug design, we have to take care of that part. An inert carrier can be cleaved off, forming a toxic product, it should also not be in the case. Product cleaving off before the reaching the target site, it also should be taken care of. Okay. And the cleaving of the carrier is also site specific. So, the site specific cleaving, it is not a problem generally. Okay. And the others are the main problem for the, and which are the limitation of the prodrug design, which we have to take care of. Okay. So, did everybody understand this, or we have any doubt regarding this question? So, basically what is a prodrug? Prodrug is the inactive form of an active drug which has to be given to our body, so that for in the cases when the actual form of the drug is have some problem, like water solubility or crossing ability to across the membrane. So, to tackle those problems, we have to give a prodrug formation which will be converted to active drug in our body. Okay. So, this was our problem number 1. Now, I will move to our next problem, our problem number 2. Okay, so the problem number 2, it says that D1927 contains a branched alkyl group shown in the blue, this one, which protects the terminal peptide bond from hydrolysis. What is the general term given for such kind of group? Number A, stereoelectronic shield. Number B, electronic shield. Number C, steric shield. Or number D, alkyl shield. So, this compound, this molecule which is called D1927, it contains a branched alkyl group which is shown in the blue here, and this group protects the terminal peptide bond, from hydrolysis. What is the general term given for such kind of group, for this kind of phenomena? Your options are stereoelectronic shield, number B electronic shield, number C steric shield, and number D alkyl shield. Now, everybody present in the class, I want all of you to try to answer this question in the chat box. Again, I am saying it does not matter if your answer is correct or wrong, but everybody should participate in the class so that we can have a better interaction. So, please write in the chat box which of the following you think is the correct answer for this problem number 2. Okay. So, steric shield, number C, number D, number C. Okay, so maximum answers are for these two. Most of the people think it is either the steric shield or it is the alkyl shield. Okay, so let us check the answer, then we will discuss. So, the correct answer for problem number 2 is number C, steric shield. So, drug stability. So, steric shields, the rationale of having a steric shield is used to increase chemical and metabolic stability, introduce bulky group as a shield, protects a susceptible functional group, for example ester, from hydrolysis, hinders attack by nucleophiles or enzymes. So, here is the example, it is also shown here. So, it is a anti-rheumatic agent. So, anti-rheumatic agent means it is used for the rheumatoid arthritis. Okay. So, it is basically used for that. So, it is the D1927 chemical reagent. So, as you can see here we have a terminal amide bond. Okay. And the terminal amine bond or this peptide kind of bond. So, these bonds are very susceptible for the hydrolysis. These amides, esters, these kind of bonds are very susceptible to hydrolysis. So, means when you are given the drug to our body, the drug is given to the body, what happen? Easily it will start hydrolyzing if there is no protecting group like this steric shield. Now, what will happen if it is degraded soon or degraded very fast in our body before reaching the target site? So, it will not have that reasonable effect for our body, right. So, that is why what we have to do, we have to introduce a group, as a bulky group which will act as a shield, and if the bulky group is here, so due to the electronic crowd of the group, the nucleophiles will not actually able to come closer to this susceptible amide or esters bond, and it will the hydrolysis will be blocked. Okay. So, some functional groups are more susceptible to chemical and enzymatic degradation than other. For examples, esters and amide are prone to hydrolysis. A common strategy that is used to protect these groups is to add steric shields designed to hinder the approach of a nucleophile or an enzyme to the susceptible group. These usually involve the addition of the bulky alkyl group close to the functional group, for example, a tertiary butyl group. In the anti-rheumatoid agent D1927 serves as a steric shield and blocks hydrolysis of the terminal peptide bond. So, what will happen, this hydrolysis of the ester or amide, it is actually happen by the attack of the nucleophiles. So, the nucleophiles, as we all know, is like this nucleophile, it is negatively charged, right. So, if there is a ester bond like this, C double bond O, O and Cr, or there is a amide bond like C double bond O, then NH, then R. So, what happens, this ketone group, it is electrophilic, and due to the electrophilicity, the nucleophiles can easily attack to this group, and it can easily cleave this terminal bond. So, this kind of groups are very susceptible for the hydrolysis. That is why what we have to do, we have to introduce this kind of group, this tertiary butyl kind of group, which is very much bulky, and due to the bulk of the steric route of the group and the steric route for the electronic cloud of the group, what will happen, due to the electronic cloud, this nucleophile will get repelled here. Okay, so, the nucleophile will get repelled here due to the electronic cloud, the negative will repel each other, and what will happen, this nucleophile will not get access to this terminal amide bond easily, and that is why this group will not be cleaved very easily, and this is called a steric shield. Okay. So, I think it is clear to everyone. So, do we have any problem for that? If not, we will move toward the next problem. Okay. So, the problem number 3, I will just erase this part. Okay. So, the problem number 3, it says that why should the introduction of an ester group into the main skeleton of the drug decreases the drug's duration of action? Number A, it makes the drug more polar and increases the rate of the excretion. Number B, it increases the molecular weight of the drug and reduces the amount of the drug absorbed. Number C, it reacts with the proteins in the body such that the drug is irreversibly linked to the proteins by a covalent bond. Number D, it is hydrolyzed by the esterases to an alcohol and carboxylic acid, which are quickly excreted due to increased polarity. Now, read the question number 3 carefully. It says, why should the introduction of ester group in the main skeleton of drug decreases the duration of the action? Read the answers carefully, each and every point of the answer, and try to answer this question. Write in the chat box which of the following you think may be the correct answer for this question. I want again I want everybody to participate. It does not matter if your answer are wrong, but still participate. The options are: number A, it makes the drug more polar and increases the rate of excretion. Number D, it increases the molecular weight of the drug and reduces the amount of the drug absorbed. Number C, it reacts with the proteins in the body such that the drug is irreversibly linked to the proteins by the covalent bond. And number D, it is hydrolyzed by the esterases to an alcohol and carboxylic acid, which are quickly excreted due to the increased polarity. Okay, option number D. So, we have 3 answers till now, and all the 3 answers are for option number D. Okay, let us check the correct answer. Okay, so very good. So, the correct answer, it is hydrolyzed by esterases to an alcohol and carboxylic acid, which are quickly excreted due to the increased polarity. Just as we discussed in our previous question, like the esters and amides are very much susceptible for the hydrolysis. Okay, means in the body, if you are given a drug which have a ester functional group or which have a amide functional group, so that drugs are very quickly they got metabolized in our body due to the enzymes, and the esterase enzyme, as you can see here. So, here it is, we have the ester functional group, right, and here we have a functional group which is kind of amide, but it is not amide, it is called polyurethane. Now, urea, we all know the structures of urea, right, the structure of urea or urea kind of bond, which is NH, C double bond O and NH. So, this bond these are present in the molecule called urea, and this kind of bonds, if the one oxygen can be present here or one oxygen can also be present here. So, basic structure is actually same like in ester or polyurethane. So, what happen, these molecules get easily hydrolyzed by this enzyme esterase, and acid and alcohols are formed, or here we have this no, it is not an acid, it is have a NH group here and also an alcohol from here. So, that is why what happens, these molecules are very much polar, this byproduct like this acid, alcohol or these are very much polar, and due to the high polarity what happen, these molecules are quickly excreted from the body, okay, and that is why the drug's duration of action is very low, okay. So, do anybody have any problem in this question? If not, we will move toward our next problem. So, again I am saying, if you have any doubt, any queries during any answer, please write in the chat box, okay. At the end of the session, I will try to answer those queries, and also please participate, and if you do not understand a point of any question, anything, you can just tell me freely in the chat box, okay. So, now I will move toward the problem number 4. Now, problem number 4, it says that Medicinal acetate has a short duration of activity since it is metabolized at position 6. This is the position number 6. Okay. Placing a methyl group at 6th position increases the duration of action. What role does the methyl group play? Okay, so again read the question carefully. Medicinal acetate has a short duration of activity since it is metabolized at the position number 6. This is the structure of medicinal acetate and this is the position number 6. Now, placing the methyl group at 6th position increases the duration of action. What role does the methyl group play? Number A, it is susceptible metabolic group. Number B, it is a metabolic blocker. Number C, it is a conformational blocker. Number D, it is an electron donating group. So, here we have a drug medicinal acetate which has a very short duration of time because it get easily hydrolyzed at this position 6. Okay. Now, if you place a methyl group here at the position number 6, what happens? This increases the duration of the action of the drug. So, okay. So, what is the role which is played here by the methyl group? And your options are number A, it is susceptible metabolic group. Number B, it is metabolic blocker. Number C, it is a conformational blocker. And number D, it is an electron donating group. Everybody try to answer this question in the chat box. Okay, we have the answers like 1B, 1 metabolic blocker, 1A and 1B. So, we have metabolic blocker and then we have A also for as an answer. Okay, so, let us check the answer, then we will discuss. Okay, so the correct answer is number B, it is a metabolic blocker. So, what are the metabolic blockers? So, some drugs, okay, let me just use the legend as a pointer. Okay, it says some drugs are metabolized by introducing a polar functional groups at the particular position of the skeleton. For example, medicinal acetate, which is an oral contraceptive. The steroid is oxidized at the position 6, this one, to give a OH group at that position. Okay, so at that position, by introducing a methyl group at position 6, metabolism is blocked and the activity of the drug is prolonged. So, what happened, this compound, particularly magistrol acetate, so what, when it is given as a drug by orally, okay, so what happened, this at this 6th position, so this is a steroid kind of molecule. Okay. So, for the, what is the structure of the steroid, it should have this kind of I mean 4 ring which are attached to each other like this, like your estrogen, cholesterol, also these are the all steroid or sterol type of molecule, and these are very prone to oxidization. Okay, and that when it is getting when it gets oxidized at the 6th position, so it will give a OH group at this position. Okay, but if we introduce a methyl group at position number 6 here, like this, here you can see. So, what will happen, metabolism is blocked. Okay. So, when you are introducing a methyl group here, the metabolism is blocked and it will not convert, OH group will not introduced in that position, and the activity of the drug will be prolonged. So, this kind of molecule is called a metabolic blocker. Why? This kind of groups are called metabolic blocker, because this kind of molecule is blocking the metabolism. Okay. So, because this kind of molecule is blocking the metabolism, it is called the metabolic blocker, and it is also a very important strategy for the designing active drugs. Okay. So, I think it is clear to all, and if you have any doubt, any problem, you can write in the chat box. Okay. So, I will check if we have any doubt or any query. Okay. So, yeah, metabolic blocker was the correct answer. Okay, very good. We will now quickly move toward our next problem. Okay. So, problem number 5, it says that what sort of therapy involves administration of an antibody linked to an enzyme such that the enzyme activates the prodrug? Number A, ADAPT, number B, GDAPT, number C, ADEPT, and number D, GDEPT. So, what sort of therapy involves administration of an antibody linked to an enzyme such that the enzyme activates the prodrug? Your options are number A, ADAPT, number B, GDAPT, number C, ADEPT, and number D, GDEPT. Again, I want everybody to try to answer this question. Okay, so do we have any correct answer? ADEPT, number C, number C. Okay. Okay, let us check. So, very good, the correct answer is ADEPT. Okay. So, in antibody directed enzyme prodrug therapy, so the full form of ADEPT is antibody directed enzyme prodrug therapy. Okay. And what is the full form of the GDEPT? It is gene directed enzyme prodrug therapy. Okay. So, in antibody directed enzyme product therapy, that is the ADEPT, an antibody bound enzyme is targeted to the tumor cells. This allows for selective activation of the non-toxic prodrug to a cytotoxic agent at the tumor site for the cancer therapy. Site selective prodrug activation results in reduced side effect in the remote tissue. So, ADEPT, and this is the target tumor. Okay. And so, the prodrug, it gives the drug which is the cytotoxic. So, here we have an enzyme E, and then there is an antibody which is specific for the tumor cell marker. Okay. and what will happen, this antibody enzyme and this antibody, it will actually bind to the antigen, okay, and systematic administration of antibody enzyme conjugation. Now, this drug which is given to the cell, which is cytotoxic to the glioma cell, okay, and this tumor specific region, and this is the target tumor. So, this is called the ADEPT or antibody bound enzyme target therapy. And what is the GDEPT, which is the gene directed enzyme product therapy. So, here tumor specific transcription gene encoding the prodrug. So, this leads to the transduction to the tumor specific foreign gene expression, and which gives the prodrug activating enzyme, and this prodrug activating enzyme will active the prodrug to form a toxic drug. Okay. So, basically this is the little bit idea for the GDPT. We will discuss these things later more in more detail. So, for right now you will remember like the therapy which involve the administration of an antibody linked to an enzyme such that the enzyme activates the prodrug, it is called the ADEPT or the antibody directed enzyme prodrug therapy. So, now we will move toward our problem number 6. Okay. Okay, so problem number 6, it says that cyclophosphamide is commonly used as an in anti-cancer therapy. Which of the following statements is not true of the above of the above structure? So, this is the structure for the anti-cancer drug which is called the cyclophosphamide, okay, and the options are, now you have to find out which of the option is not true, means the false statement. So, number A, it is relatively non-toxic. Number B, it acts as a prodrug. Number C, it cannot be taken orally. And number D, the structure is metabolized to release acrolein. You have to find out which of the following statement is not true for the above structure. Your options are, number A, it is relatively non-toxic. Number B, it acts as a prodrug. Number C, it cannot be taken orally. And number D, the structure is metabolized to release the acrolein. Again, every student present here, try to answer this question. Which of the following statements you think may be the correct answer for this question? I will discuss it in detail, but at first you guys try to answer it in the chat box. Okay, so I think everybody thinks it is number C. Okay, let us see. Okay, now let us check the answer for the problem number 6. Okay, very good. So, the correct answer is means that statement which is not true for the above structure is number C. It can't be taken orally. Okay, now let us check out. So, cyclophosphamide, it is given as a tablets. Okay, means the option number C which says that it can be taken orally, it is incorrect, right? Because as you can see in this picture, this is the picture for the cyclophosphamide tablets. Okay. Now, how the cyclophosphoramide works, like is if you can see, there is a endoplasmic reticulum, and endoplasmic reticulum, as we know, is a important part in our cells. Okay. Now, what happened? Number 1, calcium accumulation in the cytosol due to the endoplasmic reticulum mediated SCRCA2A inhibition and hyperactivated RYR receptors. Okay. So, for one thing more, you do not need to memorize everything, how the medicine works, how it everything. So, you do not need to memorize, but I am just dictating it, or I have given this figure so that you know how what these things and how it happens. Okay. So, what happened, like now, so increased calcium is taken by the mitochondria and results in the release of the cytochrome C. Cytochrome C is released due to the CP mediated ER stress is involved in the apostasis. Apostasis means the cell death. So, ER stress or endoplasmic reticulum stress immediate effect, mitochondria calcium uptake increases, ROS generation, ROS means reactive oxygenation species, oxidative damage, rate of the respiration and contractile dysfunction. Okay, rate of the respiration increases, ROS generation increases, and mitochondrial uncoupling, rate of the respiration decreases, ATP synthesis decreases, energy pool alteration, cardiac dysfunction, and due to the ER stress, NADP plus, it gives rise to this ONO, which is leads to the vasoconstriction, which is high BP and endothelial dysfunction. So, this is the pathway by which this drug works actually. So, as you can see, this is the cyclophosphoramide, which is here shown also here. Okay. So, off target oxidation. So, what happens, like this drug, when it is given to the body, this is the enzymatic system, the cytochrome P450 system, and what happened, the cytochrome C450 adds a hydroxyl group here. So, as you can see, this to this, it is converted by this cytochrome P450. This is 4-OH cyclophosphoramide. Okay. And this reversibly converted to this aldophosphoramide. Okay. And both of this leads to detoxification, and what happened, this aldophosphoramide, it makes the metabolized and gives this molecule which is called the acrolein. Okay. And this acrolein, it leads to the tissue toxicity. Okay. And then again this molecule can also be metabolized into this phosphoramide mustard, and this phosphoramide mustard, what happens, this is DNA protein alkylation or cell death. Okay. It leads to that. So, this cyclophosphoramide, at first it is metabolized to the 4-OH cyclophosphoramide, which is reversibly converted to aldophosphoramide, and this aldophosphoramide is it is actually metabolized into two parts. One part is acrolein, which leads to the tissue shock toxicity, and then it makes the phosphoramide mustard, which leads to the DNA protein alkylation, means the cell death. Now, this is the chemical mechanism by which this drug gets metabolized, and it participates in the cell death for the malignant cells. Okay. Okay. So, now this was the problem number 6. Now, quickly I will move toward the problem number 7. Okay. So, problem number 7, it says that salbutamol is an anti-asthmatic agent which shows an improved acidity over the previous catechol-like compounds. What is the strategy which was used in order to attain the improved duration? The options are: number A, substituent variation, number B, group shift, number C, chain contraction, number D, simplification. So, this is the molecule which is the salbutamol. So, here we have various functional groups like secondary alcohol, tertiary butyl group, primary alcohol group, phenol group, which is marked in different colors. So, the compound, it is said that this is have an improved acidity over the previous catechol like compounds. Okay. Now, what is the strategy which is used here to attain the improved duration of action? Is it substituent variation, or is it group shift, or is it chain contraction, or it is purely simplification? Write in the chat box which of the following you think is the correct answer for this problem number 7. I want everybody to participate and answer this question. Okay, so let me check if we have any answers for it. Okay, so the answers are number A and then substituent variation. Okay, so the correct answer is actually number B, group shift. Now, what is group shift? Okay, so we will dictate it in detail. So, group shift, removing or replacing a metabolically vulnerable group is feasible if the group concerned is not involved in important binding interaction with the binding site. Okay, if the group is important, then we have to use a different strategy, such as either mask the vulnerable group by using a prodrug or shifting the vulnerable group within the molecular skeleton. By this tactic, salbutamol, somebody wants to join. Okay, again I will start dictating from this precursor. So, the strategy which is used here in order to improve the duration of action for this molecule salbutamol is the group shift. Okay, so what is the group shift technique? So, it is removing or replacing a metabolically vulnerable group is feasible if the group concerned is not involved in important binding interaction with the binding site. If the group is important, then we have to use a different strategy, such as either marks the vulnerable group by using a prodrug or shifting the vulnerable group within the molecular skeleton. By this tactic, salbutamol was developed in 1969 from its analog neurotransmitter noradrenaline or catechol structure. Noradrenaline is metabolized by the methylation of one of the phenolic groups with catechol O methyltransferase. The other phenolic group is important for the receptor binding. Okay. So, as you can see here, I do not know it is either it is clear or not. So, this is the structure for the noradrenaline. Okay. So, the structure, I will just draw the structure here for your if you have any problems. So, the structure of noradrenaline is like this. So, there is a phenyl group here. Okay, here we have this phenolic OH and we have here a phenolic OH. So, which is basically is a catechol kind of moiety. Okay, and then we have here we have this and this. So, here we have this is a above the plane bond. Here we have OH and here we have NH2. Okay, so as you can see, this is the noradrenaline. So, this noradrenaline, it is metabolized by the methylation of one of the phenolic group with catechol O methyltransferase. So, there is an enzyme which is called the catechol O methyltransferase, which generally that compound transfers a methyl group to a catechol-like compound. So, as you can see, this is the structure of noradrenaline. We have this catechol kind of group, this two OH group which are susceptible for the metabolism, and this OH groups are converted to OMe by this catechol O methyltransferase enzyme. Okay, now here what can happen, like we can use that strategy of the group shift. Okay, and this group shift, what is happened? So, this is the example salbutamol from the noradrenaline, where in noradrenaline both phenolic groups are involved in hydrogen bonding of the receptor. Thus, metabolic methylation of one of these groups make the compound inactive and have the short duration. So, both of these OH groups are involved in the hydrogen bonding with the receptor. So, if any one of them are methylated by this enzyme, so the compound will be inactive and has a short duration. So, a solution to move one phenyl group out of the form from the ring by the one carbon only if more activity is lost due to improper binding. So, what we have to do, we just designed this compound from this compound, and what we had did, we just changed this phenolic OH group with this primary alcohol group, and we just increased the chain length by one carbon. Okay, so, this is the called the group shift. Okay, and because of the group shift, what will happen, this compound is not a catechol like structure anymore, and due to, because it is not a catechol like structure anymore, this enzyme catechol or methyl transferase cannot work here, and that's how this compound will not be inactivated fast. Okay. And since this group is only extended by one carbon, so this phenolic OH and this phenolic OH and this primary alcohol both are capable of the hydrogen bonding with the receptor. Okay. So, this was the strategy and example for the group shift drug designing strategy. Okay. So, all of these strategies are a part when where we try to increase the activity for the drug, or we keep to slow down the metabolism, so the active form of drug is present more in our body. Okay. So, the correct answer was the group shift. Now, I will move toward the next problem. So, the problem number 8, it says that which of the following is a peptidomimetic formation technique? Number A, pegylation. So, pegylation means this peg means polymer, okay, polyethyl glycol. So, by introducing this peg group. Number B, replacing L amino acid with D. Number C, N methylation, and number D, all of the above. Now, you have to identify which of the following is the peptidomimetic formation technique. Is it pegylation? Is it replacing L amino acid with D, or is it N methylation, or it is all of the above? I want everybody to try to answer this question in the chat box. Again, it does not matter if it is correct or wrong, but try to find out which of the following you think may be the suitable answer for this question. Okay, so let us see, let me see if we have any correct answers for it. Okay, so the answers are like this: number D, number D, number B. So, number D and number B are the most frequent answers. Others also try to answer it. Okay, let us see what is the correct answer, then we will discuss this peptidomimetic technique. Okay, so the correct answer is number D, all of the above. So, all of the above techniques, the pegylation, the replacing L amino acid with D, and methylation, all of the above is the peptidomimetic formation technique. Okay. So, peptidomimetics as drugs, disguising or reducing the peptide nature of the lead compound to generate a structure which is more easily absorbed from the gastrointestinal tract or GI tract, and is more resistant to digestive and metabolic enzymes. Such analogues are called the peptidomimetics. So, it has been found that linking the polymer polyethylene glycol or PEG to the protein can increase the latter's solubility and stability, as well as decreasing the likelihood of an immune response. Pegylation, it is as it is called, also prevents the removal of the small proteins from the blood supply by the kidneys or reticulotherial system. Okay. The increased size of the pegylated protein means that it is not filtered into the kidney nephrons and remains in the blood supply. The PEG molecules surrounding the protein can be viewed as a kind of hydrophilic polymeric shield which both protects and disguises the protein. The PEG polymer has this added advantage that it shows little toxicity. So, the methyl not a steric shield. So, there is an example. Okay, another strategy to flip enantiomer what we can use. Okay, so methyl group, which is the number C. So, methyl group acts as a steric shield and prevents the important hydrogen bonding interaction that is supposed to take place between the NH of the original amide and the active site of the peptidase enzyme. So, therefore, now this steric shield is present, the rates of the hydrolysis significantly go down, and so N-methylation is also one way to generate amide like or to retain the properties of an amide as a drug. Another unrelated or a completely different strategy is to flip the enantiomer that we use. So, for example, if we replace L enantiomer that is normally present in the protein with the D enantiomers, that then what happens is this makes the relative orientation unrecognizable to digestive or metabolic enzymes, especially if the side change is involved in the binding interaction. So, here is an example, you have a L amino acid, and if you convert, you have 2 L amino acids, but if you convert one of these 2 in D amino acid, it is possible that may not be hydrolyzed as well as original molecule. So, generally what happened, like due to the peptide nature of the lead compound, it is absorbed in the GI tract more easily, and it is more easily get hydrolyzed. Okay. So, now by using the peptidomimetic, what we can do, we can reduce the peptide nature for the of the lead compound, and the compound will be more stable in our body. And all the strategies are like this pegylation, which is the attaching polymer, which is the polyethylene glycol or PEG molecule to the protein, so that the stability of the compound, the peptide bond is increased, because due to the increased side of the pegylated protein, it will not be filtered in the kidney so easily, and it will not be excreted from the body. And the technique is the N-methylation. Okay, the N-methylation will actually present a steric shield which will reduce the hydrolysis, and another is the changing L amino acid with D, so that by changing the natural amino acid with the unnatural one, the hydrolysis or the metabolic enzymes can be actually action that can be reduced to a significant extent. So, all of the strategies are called the peptidomimetic formation technique, and the analogues which are used to reduce the peptide nature for the drugs is called the peptidomimetics. Okay. So, now quickly I will move toward our problem number 9. So, problem number 9, it says that which of the following is a prodrug for the nordazepam. So, the options are number A, L-dopa, number B, vemurafenib, number C, Valium, and number D, itraconazole. So, which of the following is a prodrug of nordazepam? Is it L-dopa, is it vemurafenib, is it Valium, or is it itraconazole? Everybody try to answer this question in the chat box. So let me check if we have any answer for it. Okay. Okay, number B, number A, number B. Okay, I think so. This A and B are the answers for this question, right? Okay, let us just see which is the correct answer. Okay, so the correct answer is number C, Valium. So Valium is a prodrug of this nordazepam. So this is the structure of the Valium, and this is the structure of the nordazepam. Okay, so the nordazepam so this is the Valium is also called the diazepam. Okay, so mechanism of action: enhance GABA activity, the chloride channels. Clinical effect: decreased resistance to the passive joint range of motion ROM, decreased hyperflexia, reduced painful spasms, sedation, and reduced anxiety. So this compound, which is called the Valium, it is the prodrug for this nordazepam. So when it is given to the body, this molecule, it is hydrolyzed to this active form, which has the susceptible NH group. And as I said, if this compound is given as it is, so it, as you can see here, it is a okay, one second, here is it is a amide group. Okay, so since the amide groups are very susceptible, primary amides, this is very susceptible for the hydrolysis, we have just in the prodrug strategy, we just changed this with this N-methyl group, so that the metabolism will be lower, and so this is the prodrug for this active drug. Okay, so this was our problem number 9. Okay, so now here we will have now next problem. So problem number 10, it says that L791456 is an anti-arthritic drug. Which of the following structure is not likely to be a metabolic of the drug? So this is the drug, which is the L791456. Okay, and you have to identify from this structures, the structure number A, number B, number C, number D, which of the following structure is not likely a metabolite of this drug L791456. Okay, so now this is your problem number 10. So I will just give you a break of the 3 to 4 minutes. Okay, so you just look at the question number 10 carefully, look at the structures very carefully, and try to figure out which will be the correct answer. So I am not leaving, I am just keeping my camera and my voice off, and after 3 to 4 minutes I will just be here right back, but till that time I want everybody to try to answer, look at the structure carefully and try to answer the question, which of the following you think is not a metabolite for that drug. Okay, so just I am muting myself, and I am just going to off my camera, but I am here present, and you all of you just take a break of 2 minutes, but try to answer the question as well. Okay, I will check the answers, and I want everybody to participate now and try to answer the question. Okay. So hello, is everybody present? Okay, is my voice audible and you can see my video? So I have given you one problem. Yeah, yes. So I think I have given you the problem number 10, and I think I have 3 different answer for that question, number A, number B and number C. So now let us check out if which one of the following is the correct. Okay. So our problem, it was that this anti-arthritic drug L791456. So this is the structure is this one, and I have asked you to answer which of the following is not likely a metabolite. So I have this number A, number B, number C. I have this 3 answers till now. Okay. So now I will show you the correct answer. So the correct answer is number A, structure number A. So structure number A, so it is not a metabolite for this drug. Okay. Okay. So drug stability, introducing susceptible metabolic group. So the rationally is used to decrease metabolic stability of the drug lifetime, used for the drug which linger too long in the body to cause side effect at groups when the known to susceptible to phase 1 and phase 2 metabolic reactions. So as if you can see the structure carefully, so this is the starting point which is resistant to metabolism and excessively long half time, this group, okay, this molecule. So what happened, like we have introduced a methyl group here, okay, and this methyl group, it is metabolically susceptible, okay, and the metabolic susceptible which it makes it will make the molecule more susceptible for the metabolism, and so that the drug will not linger the body too longer, and so that there will be less side effects. So as we have seen, so this was the structure of the drug. So as you can see, here are the possible metabolites. So this there is a chlorine group here, there is a hydroxyl group here. So by in any pathway of the metabolism, from this to this is not possible, okay, directly in the body, but from this to this is easily possible if you have some oxidizing agents. So this N oxide will be formed very easily. Okay. Similarly, this pyridine N oxide will also form similarly in this ring also is due to some oxidative agents in our metabolic system. Okay. And this methyl group also can be easily converted to this carboxylic acid group. Only possible metabolite which will not happen is this one. Okay. So that because of that, the structure number A is not likely to be a metabolite for the drug. Okay, so now I will move toward the next problem. So problem number 11, it says that which of the enzyme is responsible for the SCID, which is Shiver combined immunodeficiency syndrome. The options are number A, catechol dehydrogenase, number B, cytochrome C oxidase, number C, adenosine deaminase, and number D, adenylate deaminase. So you have to identify which of the following enzyme is responsible for the SCID, and SCID is the Shiver combined immunodeficiency syndrome. The options are number A, catechol dehydrogenase, number B, cytochrome C oxidase, number C, adenosine deaminase, and number D, adenylate deaminase. Please write in the chat box which of the following you think should be the correct answer for this question. Right or wrong, it does not matter, but please try to answer the question so that we will have a fruitful discussion. Which enzyme is responsible for SCID? Catechol dehydrogenase, cytochrome C oxidase, adenosine deaminase, adenylate deaminase. Do we have any correct answer for it? Okay, option number C, option number A. Okay, option number B, C and A. So we have 3 options, I think, right, or we have 2 answers, C and A. So let us check out which should be the correct answer. Okay, so the correct answer is number C, adenosine deaminase. So what is the function or what is the role for the adenosine deaminase and what is severe combined immunodeficiencies? So SCID or severe combined immunodeficiencies, so it is consists of a group of genetic disorder characterized by a block in the T lymphocyte differentiation that is variably associated with abnormal development of other lymphocyte lineages, that is B or NK lymphocytes or more rarely of the myeloid lineage. Okay. So, a genetic disorder in which both arms B cell or T cells of the adaptive immune system are impaired due to a defect in the one of the several possible genes. SCID is a severe form of the heritable immunodeficiency. The overall frequency is estimated is to 1 in the 75,000 plus minus 1000 births. So, adenosine deaminase is the enzyme which is responsible for this syndrome. So, what happened? This is the adenosine, okay, and this adenosine by with the action of this adenosine deaminase. So, deaminase means it will just remove the amine group from the adenosine, and what will happen, the inosine is formed. So, this is the structure of the inosine. So, as you can see, there is adenosine, there is water, and we will have the final product, this inosine and ammonia. So, this ammonia or this amine generated from this amine group, and this water is attacked here, and the enzyme which actually catalyzes this reaction is the adenosine deaminase. So, this is the deoxyadenosine and this is the deoxyinosine. Okay. So, this is with the help of this enzyme what happens, like this here we will have this deoxyinosine. Okay. So, this deoxyinosine, it will lead to the purine salvage, okay, and the uric acid formation also. So, as you can see, due to this DAMP, ADP, DATP. So, this all 3 into altogether is called DAXP. So, decrease in all these 3, and deoxyadenosine triphosphate, okay, it will be lead to the lymphotoxicity. So, remember this is about the severe combined immunodeficiency syndrome, and the enzyme which is responsible for this syndrome is the adenosine deaminase. Okay. So, now I will move toward the next problem. So, problem number 12, it says that which of the following statement is incorrect. So, number A, it says ticonazole can only be applied through skin. Number B, fluconazole is more polar than ticonazole. Number C, fluconazole has a better interaction with blood. Number D, ticonazole can be only applied intravenously. So, ticonazole, fluconazole, all of these are the azole kind of compounds. Okay. So, these are the antifungal reagents, and now we read all the problems, all the all the options carefully, okay, and try to answer this problem. So, you have to identify the incorrect statement. Now, this kind of question I always say, like when there is a question about the true, false or correct, incorrect, always read the question and always read the answers carefully, okay, because most of the time students get confused through the answers and the question. That is why I am asking you to read the answers carefully. So, the options are ticonazole can only be applied through skin, fluconazole is more polar than ticonazole, fluconazole has better interaction with blood, ticonazole can only be applied intravenously. So, which of the statement is incorrect? Everybody present in the class, try to answer this question in the chat box. Okay, so do we have the correct or any answer for this question? Okay, so number D are the most frequent answer. Okay, so let us see which is the correct answer. Okay, so the correct answer for problem number 12 is very good, number D. Ticonazole can only be applied intravenously. So this is the structure of the ticonazole. Now as I said, this is the azole class of compound, and so can you tell me which is the which of the class of azole is this compound belong? So as you know, this is the azole part, right? This 5-member ring with 2 nitrogen, it is called the azole. Okay, so in the chat box I want to know if you, anyone of you know which is the, what is the name of this azole group. This 2 nitrogen in 1,3 position, what is the name of this azole group? I think I have mentioned it in any previous class. I think I have mentioned this. Okay. So does anybody know what is the name of this azole group? What is the name of this azole group, azole moiety, in marked in red? Because when you are learning medicinal chemistry, it is very important to you to know the chemical class of the compounds also. As you are learning medicinal properties, yeah, imidazole, very good. So as you are learning the medicinal chemistry, you are learning about the medicinal application of the compounds, of the groups, of the various functionality, but you should also know what is the functionality calls, okay, what is the molecule, what are the chemical classes. So when there is a 2 nitrogen in a 5-member ring, okay, so it is called the azole class of compound. So this 2 nitrogen can be either in 1,2 position or in 1,3 position. So as you can see there, if here it is in the 1,2 position, so it is called the imidazole, and if it is in the 1,2 position like this, like here it is NH and then here it is N. So if it in the is 1,2 position, this 2 nitrogen, it is called the pyrazole. Okay, and then we have also kind of azole here, and it is called the triazole, and here nitrogen is 1, 2 and 4 position, right. So it is called 1 to 4 triazole. There is one, so also one kind of triazole which is like this, here there is one also nitrogen, so this is called the 1 to 3 triazole. So either we can have 1 to 4 triazole or 1 to 3 triazole. Okay. So these are the chemical class of the compounds. So this is the ticonazole and this is the structure of the fluconazole. Okay. So adding or removing a polar functional groups to vary polarity. A polar functional group could be added to a drug to increase its polarity. For example, antifungal agent ticonazole, this one, is only used for the skin infections because of its non-polar and poorly soluble in blood. Introducing a polar hydroxyl group which is more polar. So here we have added a hydroxyl group, as you can see here, and more polar heterocyclic rings which are these triazole rings lead to orally active antifungal agent fluconazole with improved solubility and enhanced activity against a systematic infection that is in the blood supply. So as you can see here, the structure of the ticonazole, so it is not polar enough to give orally or intravenously. Okay. So that's why ticonazole can only be given to the fungal infection which happens in our skin, like in our foot or in our body, any place of the body. If there is a fungal infection, this ticonazole can be given as a I think the ointment form, okay, as a ointment or cream form. So it can be given. Hello. Sorry, I think due to some internet issue, my the move. Okay, sure. Okay, so very sorry. I think due to some internet issue, the video call I get disconnected from the call. So, is my voice audible, and is the screen visible to you? Yes. Okay. So, thank you. So, where did I? When did the video call ended? I think at which part I got disconnected? Can anybody say? I was in this question, right? So, how much of it you could follow up? So, should I repeat this answer from the beginning? I remember I have just asked you to write the name of the functional group, and some of you have just written it correctly as the imidazole. So, okay, so I will just repeat this answer once more. Okay. Okay, so as you can see from the structure of the ticonazole and the fluconazole. So, the structure of ticonazole, what happens, like there is a imidazole group. So, this ticonazole is not polar enough to give intravenously or orally, but when we are introducing the polar functional groups like this hydroxyl group, okay, like this hydroxyl group or this triazole moiety. So, these groups are so much polar that this makes this molecule fluconazole to be more improved solubility and enhanced activity, and this compound fluconazole can be given to the intravenously or orally. Okay. So, this compound can be used for the systematic infections like the infection inside our body for the in the blood supply, but the ticonazole, it cannot be given intravenously, it only can be given as a form of the ointment or a cream, okay, for the fungal infections which actually happens in our body. Okay. So, I think this is clear. So, I got disconnected and I sorry for that due to some internet problem due to weather. So, I think now it is clear. So, anybody have any problem understanding this problem number 12? If not, just let me know in the chat box, I will move toward the next problem. So, is it clear to everybody? Hello, is my connection all right? Okay, please write in the chat box. Okay, so hello. So, now is it all right now? Yeah, okay, I will just move toward the next problem. Okay. Okay, okay. Okay, so actually bear with me because due to the bad weather, the connection is little bit poor today. Okay. So, the next question, the problem number 13, it says that which of the following statements regarding neurotransmitters is not true? The options are: number A, they are secreted by the neuron cells. Number B, they are chemical messengers. Number C, they basically traverse through the blood to act on a distant target cells. Number D, they carry out a cascade of reactions. So, this question is regarding the neurotransmitter, and you have to find out which of the following statement is not true regarding the neurotransmitter. Your options are: number A, they are secreted by neuronal cells. Number B, they are chemical messengers. Number C, they basically traverse through blood to act on distant target cells. Number D, they carry out a cascade of reactions. Everybody try to answer this question in the chat box. Okay, so the question number 13 was not visible, right? So, okay, let me just check my internet connection once more. Okay. Hello. So now is the slide visible? Okay, just let me just show you. So is the question number 13 visible now? Okay, so I think now it is okay. So okay, try. Okay, 1 second, I don't know what is the problem. Okay, give me 2 minutes. There is some internet issue here. Okay, I will just rejoin. Okay, everybody stay in the call. I will just rejoin. I think there is some internet issue, so I will just rejoin, but everybody stay in the call. Okay, sorry. So I think I'm very sorry for it. Okay, again I will try to show you. So is the problem number 13 visible to you? Okay, so I'm sorry, I think there is an internet issue, so I will just finish off quickly today. And anyway, I will just send the PPT and the lecture video also, so that you can check out later. And because today due to the bad weather, the internet connection is little poor. So problem number 13, which says that which of the following statements regarding the neurotransmitter is not true. Number A, they are secreted by neuronal cells. Number B, they are chemical messengers. Number C, they basically traverse through the blood to act on a distant target cells. Number D, they carry out cascade of reactions. So which of the statements regarding neurotransmitters is not true? Okay, so everybody, I think now it is audible and visible also. Okay, so the correct answer is number C and number D and then number C. So we have few answers. Okay, so let me show you the correct answer and we will finish off quickly today because due to poor weather the connection is very poor today. Okay, so the correct answer means the statement which is not true regarding the neurotransmitter is number C. They basically traverse through blood to a distant target cell. So it is not true. So neurotransmitters are chemical substances released by the electrical impulses into the synaptic cleft from the synaptic vesicles of presynaptic membrane. Then it diffuses to the postsynaptic membrane, binds to and activates the receptors present, leading to initiation of the new electrical signals or inhibition of the postsynaptic neuron. So these are the examples of the neurotransmitter: the adrenaline, the GABA, the noradrenaline, acetylcholine, dopamine, glutamate, serotonin, endorphins. So these are the examples for the neurotransmitters. So hormones versus neurotransmitters, which is I have always say. So this is actually very important comparison, which are hormones, which are neurotransmitters. So hormones are released by endocrine glands, but neurotransmitters are released by the nerve cells. Hormones travel through the blood to act on distant target cell, but neurotransmitter travel across the synapse to act on nearby cells. The effects of the hormones can be slower to build but longer lasting. The effects of neurotransmitter can be fast to act but shorter lasting. Hormones are part of the endocrine system, but neurotransmitter are part of the nervous system. So, these are the comparison between the hormones and the neurotransmitter. So, the correct answer was number C, and I think my voice is now clear and the video was visible, right. So, do anybody have any problem by listening my voice or seeing the PPT? Please bear with me today because due to bad weather here the internet connection is little bit poor, but do not worry, I will share all the slides and the videos with the NPTEL, and they will actually connect to you and they will share these things. Okay. And anyways, if there is some internet disruption, please wait for some time, I will quickly join or I will quickly rejoin. So, just do not leave, but just wait for 2 to 3 minutes, I will surely rejoin. Okay. So, this was the number 13. Now, quickly I will show you the question number 14. So, question number 14, it says that candoxatril is an ester product for candoxtrilate which inhibits protease enzyme. Which of the following statements is incorrect? So, this is the prodrug which is ester product which is called the candoxatril. So, this is the prodrug for the candoxatrilate. Okay. Candoxatrilate, and this candoxatrilate, this inhibits protease enzyme. Now, you have to find out which of the following statements is incorrect. Number A, hydrolysis of the ester reveals a carboxylic acid group on the candoxatrilate. Number B, the bicyclic cleaving group is non-toxic. Number C, the parent drug can't be administered orally whereas the ester can. Number D, the bicyclic system is electron donating and speeds up the rate of the ester hydrolysis. Now, read the answers carefully and question, also read the question carefully and try to answer this question. Which of the following statement is incorrect regarding the drug? Number A, hydrolysis of the ester reveals the carboxylic acid group on candoxatrilate. Number B, the bicyclic leaving group is non-toxic. Number C, the parent drug can't be administered orally whereas the ester can. Number D, the bicyclic system is electron donating and speeds up the rate of the ester hydrolysis. Is there any correct answer or any answer for problem number 14? Okay, option number C. So, I think the option number C is for the candoxylate, right? Okay, we will check out the answer. So, the correct answer is number D. The bicyclic system is electron donating and speeds up the rate of the ester hydrolysis. So, products to improve metabolic permeability. Okay. So, this is the group which is introduced. So, this is the group which is the candoxatril, and this is the active form of the drug which is the candoxylate. So, candoxatril is the prodrug and this is the active form of the drug. So, as you can see, it is there is a ester bond and this group is introduced here which is 5-indenyl group, and this 5-indenyl group is given as a ester for blockage for this active form of the drug, so that the acid is marked as a ester. And in the today's class itself we learned that acid groups are very susceptible, and that is why we to improve metabolic permeability we use this prodrug. Okay. So, it says that varying the ester varies the rate of the hydrolysis. Electron withdrawing groups increase the rate of the hydrolysis like the 5-indenyl group. So, this is electron withdrawing group, okay, and leaving group 5-indanol is non-toxic. So, these are the examples. So, as you can see the question, it was asked that which of the following statement is incorrect. So, hydrolysis of a ester group reveal carboxylic acid group, this is correct. The bicyclic levyl group is non-toxic, this is for this indenyl group, which is also correct. The parent drug can't be administered orally whereas the ester can, which is also correct. but the bicyclic group is electron donating and speed of the rate of ester hydrolysis. This is incorrect. The bicyclic group, this 5-indonyl group, it is electron withdrawing, okay, and that is how it increases the rate of the reaction. Okay. So, this was the example for another prodrug activation mechanism. So, now I will move toward the next problem. So, problem number 15, it says that, okay. So, I will move toward the problem number 15 then. Problem number 15, it says that oligonucleotides suffer disadvantages as drugs since they are susceptible to enzyme catalyzed degradation. Which of the following enzyme is mainly responsible for this? Number A, peptidases, number B, nucleases, number C, lipases, number D, oxidases. So, oligonucleotides are another form of the drugs which are given, but they suffer many disadvantages such the drugs as drugs since they are susceptible to enzyme catalyzed degradation. So, what is the enzyme which is mainly responsible for this? The options are peptidases, nucleases, lipases, oxidases. Try to answer this question in the chat box. Okay, we have, I think, one answer, we have two answers, one D and one B. Others also try, we will see. So, do we have only two answers till now or others also have tried? Okay, let me show you the answers, okay. So, the correct answer is yes, number B, nucleases. So, nucleases enzymes degrade nucleic acids by breaking the phosphodiester bond that holds the nucleotides together. Restriction enzymes are good example of endonucleases which cut the DNA cut within a DNA strand. A second group of nucleases which degrade DNA from the termini molecule known as the exonucleases, okay, and this is the example. So, oligonucleotides, as we know, like oligosaccharides and everything, oligonucleotides are basically the conjugation of two or more nucleotides, okay, and from the name as it is suggesting that nucleases will be the enzyme which will actually responsible for the degradation for this oligonucleotides, okay. So, quickly I will now move toward the next problem. Problem number 16, it says that why should the addition of an alcohol or phenol group to a drug decrease its duration of action? The options are as such. Number A, it acts as a polar handle for conjugation reactions, the conjugates are excreted more quickly. Number B, it increases the polarity of the drug and reduces the amount of the drug absorbed. Number C, it reacts with the proteins in the body such that the drug is irreversibly linked to the proteins by a covalent bond. Number D, it acts as an electron withdrawing group and affects the binding strength of the important binding groups. So, why should the addition of an alcohol phenol group to a drug decrease the duration of action? Try to answer this question in the chat box, read the options carefully. It says number A, it acts as a polar handle for conjugation reactions, the conjugates are excreted more quickly. Number B, it increases the polarity of the drug and reduces the amount of the drug absorbed. Number C, it reacts with the proteins in the body such the drug is irreversibly linked to the proteins by a covalent bond. Number D, it acts as an electron withdrawing group and affects the binding strength of the important binding groups. So, do we have any answer for it? Okay, number B and number A. Okay, let us check out which is the correct answer. So, the correct answer is number A. It acts as a polar handle for the conjugation reaction. The conjugates are excreted more carefully. So, that is why. So, as we know, as we have learned it easily, like in the phase 1, phase 2 metabolisms, what happened, like this alcoholic and phenolic groups, they actually form easily, metabolites are formed because they are take parts in the conjugation reactions which happens during the metabolism, and this conjugates due to the alcoholic and phenolic groups are very polar, and due to the high polarity these are excreted more easily. That is why addition of a alcohol or phenol group in the drug decreases its duration of action. Okay, so it was problem number 16. Now quickly I will move toward the problem number 17, which says that identify the incorrect statement. Number A, 6-mercaptopurine is the prodrug of the azathioprine. Number B, azathioprine is a prodrug of 6-mercaptopurine. Number C, 6-mercaptopurine gets eliminated quickly from the body. Number D, nitroimidazole group of azathioprine ensures greater activity. So, you have to identify the incorrect statement among the following. It is regarding a drug, particular drug which we will see soon. So, the options are number A, 6-mercaptopurine is a prodrug of azathioprine. Number B, azathioprine is the prodrug of 6-mercaptopurine. Number C, 6-mercaptopurine gets eliminated quickly from the body. Number D, nitroimidazole group of azathioprine ensures greater activity. So, is there any answer for it? Okay, number B. We have one answer. Okay, today I will finish up quickly because due to the poor internet connection. Okay, so the correct answer is number A, 6-mercaptopurine is the prodrug of azathioprine. So, this is the structure of the azathioprine. This is the structure of the 6-mercaptopurine. So, as you can see here, what is the difference? This is the 6-mercaptopurine and this is the prodrug for the azathioprine. Okay. So, this is the incorrect statement because azathioprine is the prodrug of the 6-mercaptopurine. So, this is the prodrug azathioprine and this is the prodrug for this compound 6-mercaptopurine. Okay. So, pharmacodynamics, mechanism of action, it is a prodrug that converted first to 6-mercaptopurine, which in turn can be converted to 6-mercaptopurine nucleotides, leading to inhibition of the de novo purine synthesis. And this is the metabolic pathway. Okay. So, generally azathioprine, what it happens, it leads to the 6-mercaptopurine, and this 6-mercaptopurine can be converted to the 6-methyl-mercaptopurine by the use of the thiopurine methyl transferase, or to the 6-thiouracil by the xanthine oxidase. Okay. And this is the 6-mercaptopurine can be converted to this 6-thiosin 5 monophosphate 6-TIMP. Okay, and then by the help of these enzymes it gets to this GTP separation and incorporation into DNA, and this metabolites, and because of this increase apostasis and decrease the blood cell replication or activation. So, this is the mechanism of action, you do not need to remember it, but remember like the names of the drug, like the 6-mercaptopurine is the active form, while the azathioprine is the prodrug for the 6-mercaptopurine. Okay. Now, problem number 18, it says that L-dopa is used as a prodrug for the dopamine since it enters the brain more effectively than dopamine. Why? Number A, it is more polar and crosses the blood-brain barrier more effectively. Number B, it is less polar and crosses the blood-brain barrier more effectively. Number C, it mimics an amino acid and takes advantage of carrier proteins in order to cross blood-brain barrier. Number D, it is less susceptible to metabolism. So, identify why L-dopa, levodopa is used as a prodrug for dopamine since it enter more effectively than dopamine. What is the reason? Okay, let me check. Okay, so we have answers like number C, number A. Okay, let me check. So the correct answer is number C. It mimics an amino acids and takes advantage of carrier proteins in order to cross blood-brain barrier. So as you can see, this is the the visual interpretation. So L-dopa basically it actually mimics the amino acid which is called tyrosine. Okay, so as you can see, in the tyrosine structure there is a OH and one phenolic OH and this group. So in the L-dopa there is two OH groups. So it basically mimics the tyrosine. Okay, and this L-dopa it actually converted to 3-OMED and dopamine by this DDC and COMET enzymes respectively, and this is the blood brain barrier as you can see, and this is the synaptic vesicles and the presynaptic terminal from the substantia nigra and the tyrosine, and converts to dopa from this enzyme and then dopamine, and then it inhibits the MyoA MyoB, and this is the all the mechanism. So just remember that L-dopa mimics the amino acid tyrosine and then takes advantage of carrier proteins in order to cross blood brain barrier, but the same cannot be done by the dopamine. Okay. So that is why L-dopa is given as a prodrug for the dopamine, so that it can cross the blood brain barrier. Now problem number 19, it says that there are several strategies for stabilizing susceptible bonds in peptides. Which of the following is not used in this respect? Number A, replace peptide link with a stable functional group. Number B, adding an N-methyl group to the peptide link. Number C, using an unnatural amino acid. Number D, replacing a D amino acid with an L amino acid. So there are different strategies for stabilizing a susceptible peptide bond. Which of the following is not used in this respect? Number A, replace the peptide link with a stable functional group. Number B, adding an N-methyl group to the peptide link. Number C, using unnatural amino acid. Number D, replacing D amino acid with L amino acid. Try to answer it in the chat box. And we have to, I think, finish quickly today because of the poor internet connection. So I am going little bit fast. But since I am going little fast, but if you have any doubt, any query, you can just tell me in the chat box, or if it is not possible today, I will definitely try to answer those queries in the next day or through the email. So do we have any answer for it? Okay, number D, only one answer, I think this is for it, number D. Okay, let me check which is the correct answer. Okay, very good. So replacing a D amino acid with L amino acid is not used I think for the stabilizing susceptible bonds in the peptides. So what is the difference of the D amino and L amino acids? So L amino acid is stereoisomer of the particular amino acid whose amine group is on the left side of the Fischer projection, and D amino acid is of the amino acid which amino group is the right side of the Fischer projection. First one can rotate the plane polarized light counterclockwise in the process called revolution, and the second one, it can rotate plane polarized light clockwise in a process called dextrorotation. Number first one, so it is superseded by R notation, and the second one is superseded by S notation used by the cell to produce protein and occur in the cell wall of the bacteria. So this was of the comparison of the L and D amino acid. So this thing, replacing D amino acid with L amino acid, is not used to stabilize the susceptible peptide bonds, but the other three are like the replace peptide link with a stable functional group like a double bond or this kind of group, adding N-methyl group or using unnatural amino acids. So this can be used for the stabilizing the group. Okay. So the last question of today's session, it says correct statement among the following regarding the antihypertensive drug enalapril is: it is an irreversible inhibitor of angiotensin converting enzyme. Number B, it is a prodrug. Number C, it has got poor bioavailability. Number D, it is transition state analog inhibitor of angiotensin converting enzyme. Now, you have to identify which of the following is the correct statement regarding antihypertensive drug enalapril. Number A, it is an irreversible inhibitor of angiotensin converting enzyme. Number B, it is a prodrug. Number C, it has got poor bioavailability. Number D, it is transition state analog inhibitor of angiotensin converting enzyme. So, which of the following is the correct statement? So, let me check the chat box. Okay, again the question is not visible, right? Okay, let me just do it once more. So, is the slide is visible right now or not? Can you hear my voice? Okay, can you hear my voice clearly? If yes, you can tell me. Yes, okay. So, now can you just look at the slides? Is the slides moving now? Can you see the problem number 20? Okay. Okay, so I will just dictate this thing because due to the internet connection I think there is some problem. So, the correct statement among the following regarding the antihypertensive drug enalapril is, it is an irreversible, it is a prodrug. So, it is the correct statement. Okay. So, now enalapril, it is an angiotensin converting enzyme inhibitor and it is a prodrug which is hydrolyzes by the esterases to its active from enalaprillate. Okay. And mechanism of action, enalaprillate competes with the angiotensin 1 for binding at the angiotensin converting enzyme, blocking the conversion of angiotensin 1 to angiotensin 2. As angiotensin 2 is a vasoconstrictor and the negative feedback mediator for the renal activity, lower concentration result in the decrease of the blood pressure. Enalaprillate may also act as on the NLS 2 that decreases to the vasodilator bradykinin. Okay. So, this is the structure of the enalapril which is a prodrug and this is the active form of the enalapril which is the enalaprillate which is an antihypertensive agent. So, this as you can see enalapril has this ester moiety and the active form has this acid moiety. Okay. So, it was, so did you was you able to look at the problem number 20 which I showed right now? Okay, so I am very sorry for the poor internet connection today because here it is weather is very bad and that is why the internet connection was poor. So, anyway I will share this lecture video because I have recorded the screen and everything. So, I think and I will just share this lecture video and PPTs also, the things which you have missed today, the things the PPTs which you could not see properly today, it will be available to you so that you can check it from there. And if you have any problem, any doubt regarding today's session or any doubt overall, you can just drop a email to me. I will just share it. I will share my email ID. Okay, so this is my email ID and if you have any doubt regarding today's class or anything in general, you can just reach me out to this to this email ID and I will share this PPT and the lecture video. And today it was the week 8 live session and again we will meet from the next day for the next Saturday when we will discuss the which will be the week 9 live session and there we will discuss the week 10 course content. Okay. So, thank you all for joining and bearing with the problematic net connection, the poor connection. So, I will just meet you next day and thank you. I will now end the call for everybody. Okay. And the slides and video I will share it to you soon. Thank you.